Welcome back to my channel Maths Made Easy. Let's continue conditional ratios part 4. Our question is, if A, B and C are the angles of a triangle, then prove that sin 2A plus sin 2B plus sin 2C is equal to 4 sin A sin B sin C. So solution, left hand side. Now we know sin C plus sin D is 2 sin C plus D over 2 into cos C minus D over 2. So same concept will apply in these two terms, sin 2A plus sin 2B. We can say this as sin C plus sin D. So it is sin C plus sin D, which is 2 sin C plus D over 2 into cos C minus D over 2 plus sin 2C as it is. Then we will take 2 and 2 common from here. Similarly, 2 and 2 common from here. This 2 and this 2 can be cancelled. This 2 and this 2 can be cancelled. So we have cancelled that 2. Then again by question, A, B and C are the angles of a triangle. It means A plus B plus C is equal to pi. We can write this as A plus B is equal to pi minus C. Then operating sign on both the sides, we are getting sin A plus B is equal to sin pi minus C. And we know sin pi minus C is sin C. So ultimately sin A plus B is sin C. So we can replace this sin A plus B by sin C. Then here is sin 2C. Sin 2C is 2 sin C into cos C. You can check, here is 2 sin C, here is 2 sin C, which can be taken common. And then we are left in bracket with A cos A minus B plus cos C. Thereafter again, question has given A plus B plus C is equal to pi. It means A plus B is equal to pi minus C. Then operating cos on both the sides. And we know cos pi minus C is minus cos C. This minus can be written in left hand side as well. So thereafter we have learned cos C is minus cos A plus B. So cos C is minus cos A plus B, isn't that? And again we have learned that cos A minus B minus cos A plus B, it can be written as 2 sin A into sin B. This is the formula. And then when we open the bracket, we get 4 sin A into sin B into sin C, which is equal to right hand side proved. Now question number 11. If A, B and C are the angles of a triangle, then prove that sin A over cos B into cos C plus sin B over cos C into cos A plus sin C over cos A into cos B is equal to 2 tan A into tan B into tan C. So solution, left hand side. Now what we do is, in the first fraction we will multiply both numerator and denominator by 2 cos A. In the second fraction we will multiply numerator and denominator by 2 cos B. And in the third fraction, the numerator and the denominator will be multiplied by 2 cos C. So please take your time to understand this one. After this, you can check, this part goes in formula. It is in the form of 2 sin A into cos A, which is sin 2A. Similarly, this is sin 2B and this one is sin 2C. And you can check, the denominator of all these fractions are same. So the LCM will be 2 cos A into cos B into cos C. And after simplification, we will get sin 2A plus sin 2B plus sin 2C. And in question number 10, we have learned that sin 2A plus sin 2B plus sin 2C is equal to 4 sin A sin B sin C. So we can replace this by 4 sin A sin B sin C. And then you can check, here is 2 and here is 4, which can be cancelled. And then we will simplify to write in this form. We have kept sin A by cos A together. sin B over cos B and sin C over cos C. And we know sin A over cos A is tan A, sin B over cos B is tan B, sin C over cos C is tan C, which is equal to right hand side proved. Our next question is question number 12. If A, B and C are the angles of a triangle, then prove that sine in bracket B plus C minus A plus sine in bracket C plus A minus B plus sine in bracket A plus B minus C is equal to 4 sine A into sine B into sine C. So, solution left hand side. Now, by question, A, B and C are the angles of a triangle. It means A plus B plus C is equal to pi. We can simplify to write as A plus B is equal to pi minus C. Similarly, the same statement can be written as B plus C is equal to pi minus A, as well as C plus A is equal to pi minus B. So, you can check over here. Here is B plus C and B plus C is pi minus A. So we can replace this B plus C by pi minus A. So this B plus C is replaced by pi minus A. Similarly, here is C plus A and C plus A is pi minus B. So we have replaced C plus A by pi minus B. And here is A plus B. A plus B is pi minus C. So A plus B is replaced by pi minus C. Then pi minus A is pi minus 2A. Similarly, this is pi minus 2B and this is pi minus 2C. And we have learned sine pi minus theta is sine theta. So sine pi minus theta. Let's consider 2A as theta. So sine pi minus theta is sine theta. Here also sine pi minus theta is sine theta. Here also sine pi minus theta is sine theta. Thereafter, we have learned the formula for sin C plus sin D. Using the same formula, we can write this sin 2A plus sin 2B as 2 sin 2A plus 2B over 2 into cos 2A minus 2B over 2. And the last portion sin 2C is copied as it is. Then here is 2, that is taken common over here. Here also 2 is common, it is taken common. This 2 and 2 can be cancelled. This 2 and this 2 can be cancelled to get 2 sin A plus B into cos A minus B plus sin 2C. I hope till here it is clear. We have copied this line from previous page as it is to avoid confusion. Now, by question it has been given that A plus B plus C is equal to pi. We can write this as A plus B is equal to pi minus C. Then operating sign on both the sides. And we know sin pi minus C is sin C. So ultimately sin A plus B is sin C. Sin A plus B is sin C. Remaining terms are copied as it is. Then we know sin 2C is 2 sin C into cos C. Then here is 2 sin C, here is also 2 sin C, which can be taken common. And in bracket we are left with cos A minus B plus cos C. Again, by question A plus B plus C is equal to pi, it means A plus B is equal to pi minus C. Then we will operate cos on both the sides. And in right hand side it is cos pi minus C, which is minus cos C. And this minus can be written in left hand side as well. So ultimately minus cos A plus B is cos C. So here is plus cos C. This plus cos C can be replaced by minus cos A plus B. Isn't that? So we have replaced this plus cos C by minus cos A plus B. Again, we have learned cos A minus B minus cos A plus B goes in the formula of 2 sin A into sin B. And on opening the bracket, we will get 4 sin A sin B sin C, which is equal to right hand side, hence proved. So our question number 13 is, if A, B and C are the angles of a triangle, then prove that cos square 2A plus cos square 2B plus cos square 2C is equal to 1 plus 2 cos 2A into cos 2B into cos 2C. So solution, left hand side. Now we will multiply this term and this term by 2 and then balance by dividing with 2. The last term is copied as it is. Then we have learned 2 cos square 2A is 1 plus cos 4A. How? Because we have learned that cos 2A is equal to 2 cos square A minus 1. And we can write this as 1 plus cos 2A is equal to 2 cos square A. So here is 2A and half of 2A is A. So instead of 2A, if we have 4A, then half of 4A is 2A. So 1 plus cos 4A is 2 cos square 2A. So 2 cos square 2A is 1 plus cos 4A. Similarly, 2 cos square 2B is 1 plus cos 4B. Then 1 plus 1 is 2. Remaining terms are copied as it is. Again, we have a formula for cos C plus cos D as 2 cos C plus D over 2 into cos C minus D over 2. Using this concept, if instead of C we are given 4A and instead of D we are given 4B, then we will have cos 4A plus cos 4B, which is equal to 2 cos 4A plus 4B over 2 into cos 4A minus 4B over 2. So the same portion is over here. So this can be replaced by 2 cos 4A plus 4B over 2 into cos 4A minus 4B over 2. Now we will take 2 and 2 common from the numerator. From this portion as well as from this portion, we have taken 2 common. We can cancel these 2. Here also this 2 and this 2 can be cancelled. I hope till here it is clear. So this portion is copied from previous page as it is to avoid confusion. Now we can cancel this 2 and 2. These 2 and this 2 also can be cancelled. So after cancellation we are getting 1 over 2 in bracket 2 plus 2 cos 2A plus 2B into cos 2A minus 2B plus cos square 2C. Please take your time to understand. Now my question, A plus B plus C is equal to pi, which means A plus B is equal to pi minus C. We will multiply both the sides by 2. Then we operate cos on both the sides. And here is cos 2 pi minus 2C. We know cos 2 pi minus 2C is cos 2C. So here we have cos 2A plus 2B. And cos 2A plus 2B is cos 2C. So we have replaced this by cos 2C and remaining terms are copied as it is. Thereafter we will open the bracket. This half will multiply 2 to give 1. This half will again multiply this 2, or you can say this 2 and this 2 can be cancelled and we are left with cos 2C and remaining terms are copied as it is. In next line, here is cos 2C. Here is also cos 2C, which can be taken common. So cos 2C is taken common, after which in bracket we are left with cos 2A minus 2B plus cos 2C. Again, cos 2c is cos 2a plus 2b. So we can replace this by cos 2a plus 2b. So again 1 plus cos 2c, and this portion we have brought in front and this portion we have taken to back, because we know if we arrange this in this manner we can get a formula. We have learned that cos a plus b plus cos a minus b is 2 cos a into cos b. So using the same concept, if we have cos 2a plus 2b plus cos 2a minus 2b, we can write this as 2 cos 2a into cos 2b. So you can check this portion and this portion is same. So we can replace this by 2 cos 2a into cos 2b. And when we open the bracket, what do we get? We get 1 plus 2 cos 2a into cos 2b into cos 2c, which is equal to right hand side, hence proved. So at last, I request you to subscribe my channel and press the bell icon for immediate notification. Thank you.